Hello, in this video I'd like to talk about vector. So in physics there are two types of quantity. One is scalar and the other is vector. Scalar is simply a number such as 1, 2, 3 or even pi. It only have size but there is no direction. However, for a vector there is both magnitude and size and direction. So for example, let's say like an arrow can be a vector and it can have like a size 3 and it can have like a direction, let's say 40 degrees to the east. For a vector, there is a thing called the component, in which that is a size along a certain direction. So for example, let's take this vector. Since it has a 40 degrees angle to the horizon, its x component, the size along the x direction, would be 3 times cosine of 40 degrees. Similarly, the component along the y direction would be 3 times sine of 40 degrees by using trigonometric identities. For calculating the size of a vector, for instance, let's say a vector has x component of 3 and y component of 4, which means along the x direction it has the size of 3 and along the y direction it has size of 4. The magnitude of this vector is simply, we can use Pythagorean's theorem, which would be component of x direction squared times component of y direction squared, which would be 3 squared plus 4 squared, which equals to 5. So the length, which means that the length of this vector is simply 5. If I want to get the angle that it makes along the x direction, then I can also use trigonometric identities, in which tangent of theta is equal to y over x. In this case, this would be 4 over 3. Therefore, I can claim that angle theta is simply arctangent of 4 over 3. Now, there are multiple operations that you can do with vectors. And first one is addition. So addition of a vector is quite simple. For example, if I have a vector v1 comma v2, and if I want to add it with a vector u1 comma u2, then this is simply v1 plus u1 and v2 plus u2. You just add the x component to the x component and the y component to the y component. The second operation is scalar multiplication. And from the name, you can kind of imply that this is a vector times a scalar, in which if I say vector v has a x component of v1 and y component of v2, then I can use the distributive property and claim that the product of this vector v times the scalar c equals to c v1 comma c v2. And the third type is called the dot product. And this is taking two vectors and would have a scalar output. So the definition of the dot product is that vector v dot producted with vector u equals to the magnitude of v magnitude of u times cosine theta, in which this theta is the angle between the two vectors. Now, this had been mathematically proven that, let's say if v equals to v1 comma v2 and u equals to u1 comma u2, then the dot product between these two vectors is simply the product of the x component times product of the y component, in which this would be v1 u1 plus v2 u2. And finally, the fourth type of operation is called the cross product, in which you're taking two vectors and it's going to have a vector output. And the formal definition of cross product is that v cross u equals the magnitude of v times magnitude of u times sine of theta times a normal vector. Now, what I mean by normal vector is that, let's say vector v is along this way and vector u is along that way, then using your right hand, you have to curl from v to u. If you curl from v to u, then the direction of your thumb would be the normal vector of v and u. And obviously this normal vector has to be perpendicular to both v and u. And obviously the cross product of those two vectors would be this normal vector times the magnitude of v times magnitude of u times sine theta, where this angle between is sine of theta.